Alright guys, in this last video of Chapter 6, we're going to be doing radical inequalities. So we just did the equations, now we're going to be doing the inequalities with like the less than, greater than, less than or equal to, greater than or equal to. So here are your 3 steps that you're going to be following. First step is you need to identify any domain restrictions before you even start trying to solve. And what domain restrictions refer back to is back in 6.3 when you were looking at the domain of like square roots. So if it's a square root or a fourth root or anything like that, you can't have any negative numbers underneath the radical. So what that means is that even indices, square roots, fourth roots, etc., cannot be negative. Cube roots can. You can take the you can take the cube root of a negative, you can take the fifth root of a negative. But if you got any even indices, you need to set that radicand, whatever's under the radical, greater than or equal to 0. And then 2, once you've got that domain restriction, you just go through and solve it. So solve the inequality algebraically, and we'll walk through exactly how to do that in the examples. Solve the inequality algebraically, and then you're going to want to check your answers. So you're going to test some different values to check your solution. Oops, sorry, that should be 2. Okay, so those are your steps. We're going to follow those 3 steps with the next 2 examples. Okay, so step 1 is we are going to identify any domain restrictions. So since this is a square root, we need to make sure that whatever's underneath it always stays positive. So domain restrictions, start with that. So we can add 6 to both sides. And then we've got 3x is greater than or equal to 6. And then to finish that, we divide both sides by 3. So we end up with this. That's like the first half of our inequality, is that we know that x has to be greater than or equal to 2, otherwise we'd have a negative under the square root. Okay, so now we go through and we solve it algebraically. So we can subtract 4 from both sides. Okay, and then remember, just like when we were solving the equations, we get rid of the index to the square root by squaring both sides. You'd get rid of a cube root by cubing both sides, etc. So squaring the square root leaves us just with 3x minus 6, less than or equal to, and then 3 squared would be 9. And then from this point, we're just adding, dividing, getting the x by itself. So we've got 3x is less than or equal to 15, and finally to get that x by itself we would divide both sides by 3. So we get just an x, and it is less than or equal to 5. So our final answer is going to be the overlap between these 2 sets. So all the numbers that are greater than or equal to 2 and also less than or equal to 5. So we would have anything that is in between 2 and 5. Okay, so that's what we're assuming is our final answer. We're going to do some different checks just to make sure. Okay, so I'll show you how to use the calculator for that. So here is what we're going to do. In a document, we can type in some different answers. So let's first check something that should be in that range, so like 3. So press 3 and then hit Control variable, and you can store that in as x. And then what I'm going to do is type in this original inequality before I made any changes. So square root of 3x minus 6, and then make sure the plus 4 is on the outside. Your symbols, if you hit Control and then the equal sign, right about here, you can see all of the inequalities. So we want a less than or equal to 7. So we're just doing a true-false check. So that's true. So the inequality that we tested is true. Now you want to do 2 other checks to make sure that anything lower and anything higher should come out false. So if we check like 1 and if we check 6, those should come out false. So let's replace the value of x with 1 and then arrow back up and test this again. Okay, so that's actually kind of a good sign because we found that we were not allowed to plug in anything smaller than 2, which is exactly what our calculator is angry about. So now let's check something like 6, store that in. arrow back up, and 6 should give us a false statement, which it does. Okay, so we can be pretty confident in our answer there. So that is just the overlap between the domain restriction and what we found by solving algebraically. Okay, so let's do the other one. Start with the domain restriction. The stuff that we have underneath the square root, since this is a square root and not a cube root, we know that that has to be positive. So to solve, we would subtract 2. And we've got 2x is greater than or equal to negative 2. And divide both sides. So I end up with x has to be greater than or equal to negative 1. So my final answer absolutely has to be bigger than negative 1. Otherwise, it will not fit in with my square root that I have. Okay, so now second step is I solve this algebraically. Okay, greater than 4. Then remember my next step from solving equations. Since this is an index of 2, technically, I square both sides. When I square the left, it just gets rid of my square root, so I'm just left with the 2x plus 2 is greater than 4 squared, which is 16. And then same thing as all these little equations. We've just got a quick 2 steps in order to get the x by itself. Remember with inequalities too, if at any point you're dividing or multiplying by a negative, make sure you're flipping that sign. It didn't happen here, but it could happen. So I have x is greater than 7. Okay, so this one's kind of an interesting one, because this one, here we started at 2 and went up, here we started at 5 and went down, so it was this nice little in-between overlap between the two. Here we've got to be greater than or equal to negative 1 and greater than 7. So if you're greater than 7, you're already greater than negative 1. So the overlap actually just ends up being this piece right here. Okay, so let's double check. Anything greater than 7. So I am going to take something bigger than 7, such as 8, and store that in as x. Okay, now I'm going to type in this inequality. So square root of 2x plus 2. Outside I've got a plus 1, and then I hit control equal sign to get these symbols. So greater than 5. Hit enter and it does come out true, which is good. Now I'm going to check something that's not bigger than 7, something like 6. And this should come out false, which it does. Okay, so the overlap between this and this just ended up being this. And if you're wondering what the overlap is, you can always just do like a quick number line, a double number line, and look for the overlap between the two. So if we say this is negative 1, anything greater than or equal to negative 1 would look like this. And then, like here's 0, 7 would be way over here. Anything greater than 7 looks like this. So if you're looking for the overlap between the two, it just ends up being like here and then anything to the right. So that's why just the greater than 7 works, because anything that is inside this inequality is also inside this inequality. Or I guess the other way around. Anything in this inequality is also in this inequality.